Okay, so good evening, and also like good afternoon for people in Europe. Welcome back to our RoboCup at Home Education Online Challenge 2020 online classroom. Today we are going to do for standard platform, the Pepper Robot, and we are going to have the fourth class, which is today we will discuss about the development of dialogue for Pepper Robots. And so today we have Luca as well, and also Amy as our RoboCup at Home Education OC. And also we have our collaborator, SoftBank Robotics engineers, uh, to bring you today's presentation. Right, so first, the arrangement is the same. So we have about 2 hours today, so 1 hour plus today. Um, You can share this link with your friends and colleagues or students if they have difficulty to enter. And just as an announcement, later on, the slides is available on the website, so you can head to our online classroom uh, homepage to find the slides. You can even download for the PDF version as well. And also, I think later Luca will introduce this our Pepper 2.9 online support session on every Monday.
Yes.
So later, I think Luca will tell you more about this. Okay, so let me go through all the announcements first. Then, as a reminder for the privacy, so all the video, uh, so all this whole session will be recorded. Please be careful on your privacy. Later on, this video will be up on social media, and at the same time, we are running this class live on Facebook Live as well. Right. So just to inform you that this is the arrangement for this class. So I will pass the mic to Luca to start the session.
Okay. Thank you very much. Welcome, everybody. So today we'll introduce the chat system for Pepper Robot. And of course, in human-robot interaction, dialogues are very important. Well, of course, also in human-human interaction. And this kind of tools have been developed in the last years for many applications. So of course, now we are interested in robotic applications, but you know that chatbots are now very, very common. Probably the majority of websites of big companies, they have a chatbot attached, so that you can, for example, ask questions and receive answers. And you are communicating not with a real human, but with a chatbot, actually. It's just a program who is interpreting your questions and provides the answers based, of course, on some database about what are the good answers for each question. So that's a very interesting topic, both in terms of research, but also in terms of commercial application. And chatbot developers is being a very successful expertise for good work position. And of course, when we have chatbot on robots, we have an increased advantage that it's the user experience is much better because you're not just reading text and writing text on the screen, but you can transform the chatbot in a real experience. So you can actually talk with your voice and you will hear the voice of the robot. So in that case, the chatbot is using the voice communication channel and not the textual channel that you usually have on chatbots on the websites. So that's why the chatbot technology integrated with robotics make a very interesting combination for applications that, of course, are very interesting and important also from a commercial point of view. So this is why all the human-robot interaction tasks are always have a component on a dialogue, and specifying dialogues may be very complex, as we will see in this lecture, and that's why it's necessary, and researchers have developed specific languages to define chatbots or to define dialogues. So because we'll see that writing the code in a programming language like Java, Python, or whatever is very, very complicated, and the dialogues may have a complexity that's in some cases very high, and so it would not be practical to write a chatbot in a programming language. So that's why in the here so there have been developed several script languages. So they are languages that are defined explicitly to model dialogues. And what we will see in this lecture is the language that is implemented for the Pepper robot. So by using this language, you can actually very easily and in a very intuitive way design chatbots that will run on the Pepper robot with no knowledge about programming language. We will see that, of course, then if you want to make it more interesting and more complex interaction between the chatbot and the robot itself, we need to integrate also the chatbot part with the Java code in this case. And we will see an example today, but mostly next lecture, next Thursday, will be dedicated to show how to integrate the chatbot with the other actions of the robot to make a very complex application. So today we'll focus on the chatbot part. And here in these links, you find tutorials of the chatbot, of the chat script language. And in particular, the QiChat is the language that is implemented on the robot. And this is a very nice feature that you can very easily test also in the simulator without the physical robot. And so it's an interesting part for the development of your project for the team. Okay, so when, of course, dialogues means that there is the human and the robot that are producing speech voice commands, and it is important to understand what are the roles. So in a dialogue, we have usually the roles of the speaker and listener, and these roles change over time, of course, depending on the situation of the dialogue. So that's very important because as humans, we usually have the capability, maybe not always, but most of the cases, we have the capability of understanding when a person is talking and the other people involved in the conversation will not talk or will just listen. And we have some mechanisms to, for example, to pass the turn, so to communicate that it's the turn of someone else to speak. While for the robot, of course, this is more complex, and the robot is using this visual communication signal to communicate that which is the status of the robot with respect to the conversation. So the bar of the top bar of the tablet and the colored LEDs that are on the shoulder of the Pepper robot have colors that have a meaning in terms of that are useful for the conversation. So when these LEDs are off and when the bar of the tablet here is gray, then it means that the robot is not listening. So if you speak while the robot is in this state, the robot is not listening to you. So what you said will not be captured and will not be interpreted. While the robot is listening when it's in this state, which you see this top bar colored by this light blue, and the shoulders LEDs are active. So that's a social signal that the robot emits for the human to understand when the human should talk and when the robot is listening to us. Now, we will see that, of course, in the emulator, we don't have the physical robot, but the display on the Android tablet, the virtual tablet, is reproduced. So you will see that when you use the Android Studio emulator, the top bar of the Android tablet is either gray or blue, and this state is also enabled. So it means that also in the emulator, you will recognize the state of the robot. Okay, so how do we define conversations? And we have to implement these 3 steps. At least these are the basic steps to implement a conversation. Then we will see a little bit today and much more in the next lecture. That, of course, in order to integrate the conversation with other actions, this would require additional steps. So the basic steps are to define a topic, and we'll see that a topic is just, it's actually the specification of the dialogue. So we'll see it's a set of rules that will map the user input with the robot input and will actually implement the dialogue. Then from this topic, we define a chatbot that is a data structure that manages the topic, and then a chat action that is the action that is actually executed by the robot. So we'll see that the topic component is using a script language. So it's not a programming language, but it's a script language in which you define at a more declarative level what are the rules that will implement the dialogue, while the chatbot and the chat actions are pieces of Java code that anyway are independent from the topic, so from the actual dialogue. So this means that, of course, the topic and the rules here are specific of the particular dialogue that you want to implement, that you want the robot to run, while these other components are general components. Okay, so this also means that after you understand the example that I will show you today, that it's also available in the GitHub repository. And if you want to just change the behavior, so the dialogue, the information that are, the flow of the information that are used during the dialogue, you need to change only the topic, and you don't need to change the Java code, because the topic is the only part that is specific of the application. Okay, so what is a topic? So a topic is the definition of a set of rules that implement the dialogue, and it's using a script language that is specific. You can create the topic by using Android Studio, and there is an item in the menu that is chat topic. And when you create a chat topic, a new file is added to your project containing a basic definition of a dialogue that is already working. So by just creating this file on the menu, and by having this particular piece of code, which is a very simple specification of a dialogue, you can even directly run the project, so without writing anything else, and you will have the robot interacting with you. And you can say hello to the robot, and the robot will answer hello. You can say hi, and the robot will answer, and so on. So this means that a very basic chatbot you can obtain without writing any code in the chat topic. You have to write a little bit of code that we'll see later on to define the chat action, but not on the chat topic. So we will go, of course, more in details about the meaning of this language and about what are the functionalities that we can add in order to make the dialogue more complex. So before we do this, let's complete the process. So let's leave this chat topic as it is without any change. And let's see how we can integrate the topic, the chat topic into our programming environment. So what we have to do is, as mentioned before, is to write a few lines of code, of Java code. This is actually the creation of an action. And this is an action similar to the actions that we have seen in the previous lectures, like the say action or the gorilla action. You remember that what we did is to create an action and then run the action. So the chat action is an action like the other ones, and the action is created with the creation of a topic, of a chatbot, and then the action itself. And everything is driven by the topic resource that is exactly the file that you just created. Okay, so you see that this is quite simple. You just have to take this code and copy this code into your project. You create a new chat topic, and at this point, when you run the chat action, this will actually run the chat behavior of the robot that will reply to this, will apply these rules. So we'll see in a while this, but before we go ahead, let me show you this example, very simple. So here you see a project that already contains a more complex definition of the topic, but actually to start a very basic topic, what you can do is that you go here to the file menu, then the new, and then you find here the chat topic. And when you click here, you just have to give a name to the topic, whatever it is. And this is the name of the topic should say something about what is the topic about. You can have more topics, many topics in a single application. And then we'll probably show this later on that you can also have a multi-language chatbot. So the creation of the first topic is in the default language, but then you can have translations of the topic so that the robot will be able to speak different languages. And so you create the topic and you get the topic that we've seen before. Okay, so you get a topic with only this, let's say this example. And if you just have to comment the two lines. So when you use the dash symbol, this means that this line is not part of the specification, where it's just a comment. If you remove the comments to the concept and to the user rule, then you will have a topic. And now you will see that the topic is actually a file that is added to your project. Now this is, I call it hello. So you have this hello into the resources of the project. And so in order to run a chat action associated to this topic, you just need to add this code that we've seen in the previous slide. Okay, this one, in which here you specify what is the topic that you want to associate to the chat action. Now, here we have the association of the greetings topic, which is the topic that I will show you today. So it contains several definitions of an interaction which is more complex. But for example, if we want to consider only this topic here, we can very easily replace the name of the topic that is that was greetings, but now we can use hello, which is the very simple topic that has been generated when I create this topic, and I can run this application that will actually create the chat action that is associated to this topic, and it will just run the chat action on the focus gain method. So this means that when we start this application, the chat action will start immediately. So this application is directly related to the chat action. We will see in the next lecture that like in the previous lecture, that in general, we have several actions available, and we have to make these actions to interact each other to specify a complex behavior. This is something we will see later on, but for today, we'll just focus on the chat action. So the application will just run the action itself. So here in the onRobot focus gain, which is the method that is run when the application starts, the chat action is run. So what is the effect of this program? That if I run, I will have that the here I will see the screen of the tablet, in which I have now just the hello world and the chat started, hopefully. And we can interact with the robot, with the simulated robot, by using the dialog view. Okay, so here we can write the text. So another thing that is quite interesting is to check that everything goes well. So we have also, if you move here to the log window, you can read the output. And there will be also another video that will be more specific about this, because of course it is not easy to interpret all the error messages. And here you can find some feedback about what's going on. Okay, so let's go back to our original topic, because this one has some additional features that we want to focus. So as usual, we can stop the application here and go back to our topic. That is instead the greetings. And so I want to show you some additional components. Okay, anyway, the greetings topic has many other components, but it contains the same that are generated by the default creation of a topic, but you see that contains also something else. So I would like to show you step by step what are the meaning of the instructions that we are using in order to understand how to create a, let's say, moderately complex chatbot. We'll not go in all the details. If you go to the documentation, you'll find many other functionalities that we'll not cover in this lecture. But I think that even these basic functionalities that we will see today, they will enable the possibility of creating quite complex interactions. So as usual, all the people who are also involved in the organization of the competition and in the preparation of this material, please enter at any time in this lecture. So also people from SoftBank. So do not hesitate to interrupt me at any time if you want to add more information or to give additional examples. Okay. Okay, so let's start from the first important concept of the dialogue, that is the concept. Sorry about the multiple use of this term. So a concept is an association between words or sequences of words and a semantic meaning. So we know very well that, of course, there are in the language many synonyms when we want to express something. And of course, it's very important that we assign some meaning to what we say, because dialogue is effective, of course, only when the robot is able to understand the semantic meaning more than the single words. And this will also make the interaction much more intuitive and natural. So a concept is something that can associate a semantic meaning to some words. And so the specification, as you see in the slide, is in this QiChat script language, is the keyword concept. That means that we are defining a new concept. Then the name of the concept, that is enclosed in round brackets, and a list of words or sequences of words that are enclosed in square brackets. So this means, what is the meaning? The meaning is that in this chat, in this topic, we consider hello, hi, hey, good morning, and greetings as equivalent words that can be used to express the concept hello. Okay, so it means that in this chat, we consider these 5 sentences or words equivalent. And so if the user say hello, or if it says hi, or if it says greetings, then all these words or sentences will be considered equivalent and will be considered as the expression of the hello concept. We will see this is valid both for the human and for the robot. Okay, so the concepts are not associated to only one agent, but they are associated to any agent. For example, bring, get, take can be considered as synonym of a concept that we call bring. And this other one is a little bit more complex definition, in which we use an additional syntax with this the curly brackets that allows for optional parts. So, for example, the fact of using the word please before something can be considered optional. So this means that with or without please, we consider that this is the same concept. And also concepts can be used to define other concepts. So here we have the concept bring, that is defined as the list of words bring, take, and get. And here we use the concept bring, so we use the tilde symbol to denote a concept to define another concept that we call it bring me. So this bring me concept is a concept that is defined with the bring concept. So here means that I can use bring, get, or take, and optionally I can use please before and me, some, and hey after. So this means that if I say please bring me, or please bring some, or bring me, or take me, or get some, so all the combinations of words will denote the bring me concept. You see how powerful is this mechanism that allows to define actually a set of sentences with the same equivalent semantic meaning. This is very important because, of course, we cannot predict if the user will say exactly, for example, bring me a Coke, or maybe the user will say, please bring me a Coke, or please bring a Coke. So we cannot write down explicitly all the possible, let's say, combinations of words that the user will say to the robot. So it's very important to define this at a more abstract level in this way. Also, you see that this is very easy to extend. For example, assume that there is a user who is using a different verb to express the fact that he wants something. You can easily add this verb here without changing all the rest. Okay, so the definition of concept is very important because we move from the textual sentence to its semantic meaning. Okay, now that we have concepts, what we can do is... Yes.
Hello?
Yes?
Yes, I just wanted to a bit bounce on what you were saying about concepts.
Sure. Thank you.
Just saying that in the real world, in real world application development, this is indeed very important for two aspects. One is that we often will write a dialogue or the kind of things we expect the human to say, and then test it with real people, and we'll quickly realize that people will speak differently and not say exactly the way we expected. And then we have to go back and change the concepts.
Yes.
And this is like a very iterative process. That's why the QiChat is very powerful for this. And another aspect is that you illustrate here well, is that often the name of the concept is still grammatically equivalent to what you use inside it, like bring. And this makes it easier to keep track of how your dialogue is organized. For example, if I read the sentence, please bring me some please bring me works grammatically, even though actually bring can be replaced. And generally we use concepts. The names of concepts would pick a name that corresponds to what's in it or what could be in it, so that the sentences read like normal sentences, even if actually the robot is recognizing a wide variety of patterns.
Yeah, exactly.
It's a way of keeping your code manageable.
Sure. Thank you. That's very important. That's why this script language is very important, because it can be easily extended. You just add one more verb if you see that the user is using a different verb with respect to what you predicted, or maybe the user is say, "Hey robot, please bring me some something," and then you have to add the "Hey robot" as an optional term. So it's this language has been designed exactly for having a very simple way of incrementally develop the topics. Thank you very much. So once we have all these topics, it is important now to specify the rules of the interaction. So the second element that is fundamental in the QiChat language is the rules and also subrules. So rules in general are rules that associate robot replies to human input. So the syntax of this rule is very simple. We have the U, that is the specification that we are defining a rule. And then in round brackets, the human input, and after that, the robot output. So in principle, we can use directly words or sentences. For example, in this rule, we say that when the human say hi, the robot will reply hello. So it's very simple. It's whenever the robot recognizes that the human said what is in the round brackets, it will emit what is after that. But the problem, you see that if you write directly one word, then of course this rule will be activated only when the human say exactly hi. And if the human say hello, this rule will not apply. And so it means that you have to write many rules, but this will be very complex. While the use of concepts like this one, this is very convenient because what you can say is that when the human input, when the robot understands that the human input belongs to the hello concept, so it means that the human has the intention of greeting the robot, then the robot has to reply with hello. So you see here that hello is denoted with the tilde symbol. And so this is a concept and not a word. Okay, that's the difference. When you write hello without the tilde, then you are specifying the word hello, while the tilde hello syntax specify the concept. So what is the meaning of this rule? This is very important. It says that if the human input belongs to the hello concept, then the robot output also will belong to the hello concept. But what is the hello concept? The hello concept is a set of words. So when the concept is interpreted as human input, this means that any of these words can match the rule. So this means that this rule will be activated if any of the words that are defined in the hello concept are given in input. So if the robots, if the human say hi, or if the human say greetings, or if the human says good morning, they are all valid words that will activate the rule. And then this is used also as a robot output. So when the robot output is a concept, then any of these output will be valid. And here we will see that there are functions to specify how the robot will select what to say. So if we don't say anything, we will have the robot choosing these sentences in the given order. So first time you greet the robot will say hello. The second time will say hi. The third time will say hey. And then we'll go ahead like this. So this is very interesting because it's starting to show some nice interaction with the robot that does not require you to write too much code. So we can see an example of this running. So now this topic here that I'm running now is more complex, but I will show you just this part. Let me take this out for a moment because I will show you this next proposal later on. So I want to show you now just the use of the concept hello. So let me also take this out. Okay, so let's consider only the concept hello, which is exactly the one that we have seen in the previous slide, and the rule that when the human input is the hello concept, then the robot output will be the hello concept as well. So if we run this application now, we see that you see here the robot is listening. It's blue, and it means that when I write something here, the robot will listen to me. So I write hi, and hi is recognized as part of the concept hello, and this rules has been applied, and the robot replied hello. And if I say another sentence that is in the same concept, like hello, the robot will say hi. Okay, so we can keep going here, and you see that whenever I say something that is in the hello concept, the robot replies. And you see that if we don't specify anything else, the robot output will go through all this list. So you see first time it replies hello, then hi, then hey, then good morning, greetings, and then go back and start again with hello. If we say something that is not matching any rule, like, I don't know, so this sentence does not match any rule, and so the robot will just not reply. And this is also another interesting thing that you can do, is that if you see that a human is willing to interact with the robot, asking what is the weather, sorry, here it's not spelled correctly, but it's not important. Of course, you can add additional concepts. Okay, so this is an important concept. And the other one is the possibility of adding the sub-rules. So sometimes we want to add a state of the conversation, because of course during conversation some answers may depend not only on the last questions, but also on the previous ones. So it is possible to create nested rules in such a way that we understand the answer of a user in the context of the previous answers. So for example, in this rule here, this is a little bit more complicated, because we see not only the main rule, which is the first one, but also the other ones that are sub-rules or nested rules. So here the first rule says that when the human say hello, or say whatever is in the hello concept, the robot will reply with do you like animals? Of course, also here you can have a concept to express this question, but in this case, for a simple example, we're just using direct sentences. So now the robot is waiting for the answer on this question, and it will activate the sub-rules that are denoted with U1. So U is the rule at the top level, U1 is the rule at the first level, and U2 is the sub-rules at the second level, and so on. So here now, after the robot asks, do you like animals? We are at the first level of the sub-rules. So the rules U1 are enabled. And it means that if the user say yes, then this rule here will be enabled. If the user say no, then this other rule is enabled. So if the user say yes, then the robot can continue the interaction and say, which is your preferred one? Okay, and then we enable the second level of sub-rules. And it means that if the user say dog, then the robot will reply, I also like dogs. If the user say cat, the robot will reply, cats are very nice. Of course, you can continue this interaction as much as you want. So it's very interesting, because this means that, for example, this rule U2 will apply only when we reach the status after the two interactions. And this means that if you say dog before reaching this state, the rule is not active. So if you say dog at the beginning, the robot will not reply, because the reply to dog is enabled. So this rule is enabled only after we reach the situation. So this is very important to create interactions that depends on the behavior of previous interactions. And it's, of course, a very convenient way of implementing this. Of course, you cannot go too much into too many levels because it's very difficult to predict complex interactions like this, but this is very convenient way, especially when the robot makes questions and when you want to reply differently with respect to the answers of the human to robots questions, then this, of course, is a very convenient way to have rules depending on the current state of the dialogue. Okay, I don't know if anyone wants to add something here. Okay, if not, we can go ahead with the introduction on another concept that is very useful, that are functions. So functions are elements that are used in the language script in order to define some way of using the concept, for example, or of using the rules. So we will see two functions that are applied to concepts that are very useful. The rand function, so a function is denoted in this way with this affix symbol before the name of the function. And for example, the rand function will randomize the choice of the output. So the rand function is affects only the robot output, and when the rand is applied in front of a list of terms, it means that when the robot has to choose one element from this list, it will do it randomly. So we have seen in the previous example that the robot was rotating, so was using these elements sequentially. While if we want to randomize the way in which the robot answers, we can add the rand function. The first function we'll see in a while that it's has a different meaning. So it will go through the list and it will return the first available expression. We'll see in a while that this is very important, for example, when we use variables in which some of the alternatives may not be valid at a certain point of the interaction. So first means go through the list and return the first sentence which is valid. So this is a very important function that is used when the list may contain not valid, non-valid entries. We'll see an example in a while. And then when we have proposals, we will use some other functions that I will comment later on. Okay, so also another concept that is very important is the concept of variables, because very often we want to continue the interaction depending on what the users say, and we want also to remember what the user said. So for example, the robot can ask to the user, what's your name? And the user can answer his or her name, but then the name may be nice to be remembered by the robot. So in this way, what we can do is to use the concept of variables. So the concept of variables is implemented in this way. In the input in the input section of the rule, we can denote the name of a concept or the asterisk. Asterisk means anything preceded by the underscore. So underscore something is can be used in the input section of a rule to denote some variable element. And then in the robot output section of the rule, we can address this variable part of the input with this syntax $1, that is the first element, and if there are many other elements here, we can access them with $2, $3, and so on. So $1 means the first variable element that we find in the input. So for example, if after what's your name, we say our name, and you see this is a sub-rule, so it's enabled only after the first interaction, then this name is retrieved by the $1 syntax. And so the robot will say hi, and it will repeat the name of the that is being mentioned by the human, and then the words "nice to meet you." For example, if the robot asks what's your name and I answer Luca, the robot will say, "Hi Luca, nice to meet you." But in addition to this, we want to remember the name of the user later on. So what we can do is to use a specific name of a variable. For example, here we use the variable name, and we can assign with the equal operator the value $1 to the variable that is denoted with $name. So this means that I remember also in the future, in the next interaction, that the name of this name is Luca. Okay, so when the robot asks what's your name, if I answer Luca, this term Luca is memorized, is stored in this variable. And later on, for example, when I say bye, the robot can say bye-bye Luca, because now the robot knows that that is interacting with me. But of course, there may be situations in which I don't get to the point of answering my name, and so maybe the variable name is not enabled. In that case, if the variable name has not been assigned, so if we never reach to this condition, this means that the name is not valid. And that's why we need to provide to this rule two options. So one is bye-bye with the name of the person, and another one is bye-bye without the name, and use the first function. So first function is used in this way. We go through this list and we select, we return the first valid expression. So when name is set, it means that this rule has been executed, then the name variable is valid, and the first function will return bye-bye and the name of the user. While if name is not set, then this is not valid, and the first function will skip this and will return the next one. If you don't put the first function here, you can get an error. Okay, so without first, the system will select, for example, the first item, but if the first item is not valid, you can get an error, or if you don't get an error, you can get anyway that sometimes the robot will say bye-bye without your name. Well, in this case, with first, you are guaranteed that if name variable is set, then you always get this form with the name, while if the name variable is not set, you always get this other form. Okay, so let me show you also this example, and now we implement all of them. So let's start with the next, with the rand. So we add now a rand function to randomize the hello concept, and we have also the concept about my name is. And here we see that this is implemented in this way. If there is a word, an input, in which the first part is the concept my name, that can be my name is, or I am, or I'm, or whatever you want to add here. And then the second part is a variable part, underscore asterisk. then this is interpreted as the fact that the user mentioned his or her name. So the robot answer, hi, it will repeat the name, and then nice to meet you. But then it also sets the name variable, so that later on, for example, when you use by, it will mention this name or not. Okay, so yeah, we changed something. So let's restart the application. You can use this button here to restart the application. And now we see, for example, that if when we greet the robot, it will reply in a randomized way. So you see that it replies good morning, hey, hello, greetings, hi. So it's not anymore following the sequence, but it's just randomizing the replies. Now, I can ask, what's your name? And the robot replies, I'm Pepper. So here I'm using this concept, what's your name? And this rule that when the user says the concept, what's your name? The robot replies, my name is Pepper. But I can also say, my name is Luca. And you see that now this other rule has been executed, and the robot understands my name, Luca, and it says, hi, Luca, nice to meet you. Now, if I say bye, the robot will reply, goodbye, Luca. Okay. Let's start again this. And because I want to start again without the name, you see that now here, if I say bye without specifying my name, the robot will just reply, bye-bye, see you soon, but without my name. If I say I'm Luca, and then I greet the robot now knows that I'm Luca, and it will reply bye-bye, Luca, and so on. So also in this case, you can see that the bye concept is a concept in which we have used some typical words that or sentences that we use to say bye or goodbye. And again, we use the run function to randomize this output. Okay, here you can see some other example like the bring me. And so you can say the robot, can you please bring me some food? Or only take food, or please get food. So you see that you have a lot of variabilities to write a sentence that has the same meaning. And here now very simple, the rule bring me something, it will reply something like, okay, which kind of whatever would you like? Okay, and the final thing I want to show you is the use of proposals. And so proposals are very interesting because it allows the robot to be proactive in proposing something to the users. So for example, you can define some predefined questions that or interactions for the robot, and you can drive with the functions these interactions. So here we see that there are some proposals. One is how are you? Another one is what's your name? Another one, would you like some drink? Okay, and in order to activate these proposals, we can just add here in any concept the function next proposal. So now we change this rule, and we say that when the user say hello, then the robot will answer hello, and then we will show the next proposal. So next proposal means that it will go through the proposals and it will iterate over these proposals. So first time it will show the proposal, how are you? And this is the interaction. The second time it will ask what's your name, and this is the interaction. Third time it will ask, would you like some drink? And this is the interaction. So if we start this, I have to restart because I changed the next proposal tag here. Now we have the behavior that whenever we say hello to the robot, again by using the hello concept, you see that now the robot is saying, replying, so greetings, and then it's adding, how are you? So we are here. And here we can say, we can reply, fine, and the robot will also say, sorry, that's wrong, because I am is another rule. Okay, so the robot now replied with a different rule. Let me go ahead, and now we say hello again, and the robot move to the next proposal, and it's asking now, what's your name? And here I can reply my name. And here, this is a different rule in which but it's similar to the one before. So now the robot knows about my name. If I greet the robot again, then the robot is moving to the third proposal. And it says, would you like some drink? And you see that here we have a more complex interaction, in which I have at the first level 4 options: Coke, beer, wine, or nothing. And then if I choose wine, there will be another interaction in which the robot asks, do you prefer red or white? And then you can choose red or white, and you will get some different answer. Also, it's interesting that here we are using another function. So for example, when we ask for beer, the robot says, sorry, I do not have beer. But in this case, we don't want to exit the dialogue or this interaction, but we want to keep the robot in the interaction, because maybe we want to give the opportunity to the user to say something else. So this function stay in scope means that after the reply, the robot is still waiting for an answer. So it means that now we can answer beer, and the robot says, sorry, I do not have beer, but is still waiting for an answer. So we can say Coke, and now the robot replies, yes, I have a Coke. Okay. Otherwise, without this function, the robot will just exit the conversation when you say beer, and it doesn't give you the opportunity to add an additional option. So you see that this is very important, because when you are in a dialogue, you can have situations in which when the user says something, you want to keep stay in the same context, in the same scope. And this is how the stay in scope function works. Okay, so finally, maybe you noticed that during the interaction, the robot is displaying in the screen the name of the user. I will show you again this, that here the screen just shows the default text hello world, and as soon as it gets the name of the user, let me change it, because of course, we can use any name. So I'm using Jeffrey's name. And if I say to the robot, my name is Jeffrey, then the robot will understand this and will display. It's not displaying. Come on. Okay, sorry, I think there is something here we have to fix, but anyway, you have seen that in addition to remember the name of the user, when we say bye, now the robot will reply with the name of the user, it's also displayed here. So this is something that is done externally with respect to the topic. And I will show you quickly to complete this lecture today how to do this. And you find here the code. So now we start looking at a very simple interaction between the chat topic and the Java code. We'll see much more in the next lecture. And so in the Java code, we can easily write a listener. So a listener is a piece of code that is executed corresponding to an event. So here, what we have defined in the Java code is a listener that will be executed whenever the event happens. And the event is the change of the value of a variable in the chatbot. So in this way, we can define a name, a variable, a chat variable, with the name that is exactly the one that we use in the chat topic. So here we have the name that is name, that is exactly the same name of the variable that is used in the chat topic. And then we can add to this chat variable a listener when the value is changed. So this means that whenever we change the content, the value of this variable, it means whenever we reach this rule in the chatbot, then this part of the code is run. Now, what is doing this part of the code? Well, first of all, it's writing something on the log window here, but also it set the text of the text view in the tablet. So here, the tablet contains only one text field. The type of this is text view. And the identifier of this element in the graphical user interface is text view 1. So we can easily access this in the Java code by using this expression, the find view by ID, that given the ID, in this case the ID is text view 1 that corresponds to this one, will return an object. And then with this object, we can use the method setText to change the value here. And we want to change the value here by composing a string, which the first part of the string is hello, and the second part is the actual value of the chat variable. So here, this means that when this rule is applied, and the value that is understood by the robot is associated to the name variable, then this value can be used in this portion of the code. For example, to compose a string hello concatenated with the name of the user, and to display this string in the text view element of the screen. So this is a very simple example in which the dialogue can produce an except outside the dialogue itself. So not only now this name is used into the dialogue, for example, to say goodbye, Jeffrey, but also can be used outside the dialogue, for example, in the user interface. And what we'll see in the next lecture is a more advanced way of integrating the chat topics with the actions of the robot. Okay, so that's it about this example. You will find all this application in the RoboCup at Home Education Git repository, and this is called the basic chatbot. And you will find these rules, so you can play with it and of course improve them or change them. And you will also, I will also add here a link to a YouTube video showing again all these steps of creating a chat, and also to debug, to understand how to log and how to debug things. So you will find in the slides that will be published in the web page of the also a video here, and then of course again you find additional material on the GitHub where you find other QiSDK tutorials, and I don't know if before we go ahead, people from SoftBank, you want to add something? Okay, doesn't seem so. Okay, so what is the assignment?
Actually, sorry.
Yes, yes.
Sorry, I was at a very noisy environment. I was trying to move to somewhere less noisy. Is my microphone here set up correctly? Yes, just wanted to maybe a bit of a comment on your examples there. There are several ways of doing it. With the U and all that, the U1, etc. In that the way the QiChat was originally designed was very much in the line of making chained dialogue like this. And this is actually very similar to what you might find in a video game, like when you have branching dialogue trees. In practice, we often move a bit away from that, in that we try to prefer to make dialogues that mostly have top level rules, like only the first level U column rules, and only use so that basically at any time, if you say something, people will have the correct reaction to that. Sure. Even though the way you do it here works fine, but like with small triggers, those kind of small triggers, Coke, beer, etc., will not work well as top level triggers because they might be triggered too often. Just wanted to be aware that there are kind of two ways of designing the dialogue, and that often you get a slightly better experience with a more open dialogue, where at any time you can say anything and Pepper will have a response to it. And even try to phrase Pepper's questions in a way such that the answer would also make sense as a top level question, if that makes sense.
Yes, I perfectly agree. And of course, this also requires some experience from the chat designer, let's say. And so what you say is perfectly right. And you gain this experience, of course, with many development of applications. And I think that this will also happen. I also invite all the students to make this exercise that maybe a few members design the chat and the other one will test it, so that you can understand, for example, what are the limitations or the drawbacks, because sometimes when the designer chooses some rules, then of course it's very difficult to predict everything that may happen. And then with experience, you'll probably understand that there are some functionalities that are better in terms of more likely to be successful. On the other hand, you know that this kind of menu style of dialogues is kind of conservative. So it means that, for example, if the user, the robot says, I only have Coke, beers, and wine, so what do you want? So in a way, is if when the robot drives the dialogue, then usually we have a better success rate because the environment is easier. But on the other hand, we have less interesting user experience. Having the open dialogue in which the user can say anything at any time, of course, is much better in terms of user experience. But sometimes, of course, depending on the system, especially, of course, when we apply this on the real robot, maybe in a noisy environment, when you have a completely open dialogue, this may not result in a fully successful interaction. So, well, I think that that's the task of the designer and the developer of the application to understand which is a good level. And of course, this will come with experience. So yes, thank you very much for the comment, because I think that, of course, is very appropriate. Okay, so just to conclude, then maybe I will collect some questions and we can answer some questions. I would like to invite all the teams to use the chat language to improve your project. So in the first assignment, you develop a robot that just talks, so just explain and illustrate the information about the team. And now we want you to develop an application in which the robot answers about your team. Okay, so try to invent an application using the chatbot tools that we have seen today, in order to have the robot answer questions about your team. And you can take, for example, inspiration from the questions that you answered when you fill the registration form. So questions may be like, what's the name of your team? How many team members? Where are you from? What's your school? Do you know Ross or whatever? So you can imagine that the user will make questions similar to the ones that are illustrated in the registration form, or you can, of course, imagine any other question. And you have that the robot, the goal of the robot is to answer these questions about your team. Okay. So you can have either a simple application like this, so an application in which the chat action is run directly in the on robot focus gain. So you focus only on the chat, like in this example. So in this case, you have just to change the chat script. You don't have to change anything in the code. Or otherwise, if you want, you can add the chat. You can link the execution of the chat action to the start button, like in the exercise that we have seen in the previous lecture. Okay, so this is the assignment, and you can do it by continue to work to the same project that was already assigned in the GitHub Classroom. So you can evolve your project, the project that was introduced my team, now not only by having the robot speaking, but also adding the functionality of the robot to answer questions using, of course, the chat interface. Okay, let me also remind you that we are giving possibility of teams to meet us on Mondays, 2:30, 3:30, Central European Summer Time, so time zone of Paris and Rome. And with this link, so all the teams are invited to join this meeting session in order to solve problems, but also to discuss about the situation of your team. So it's very fine if you connect and maybe even if you don't have direct questions to us, or maybe just listening to the answers of questions of other teams can be beneficial, or maybe you can ask some information about how to develop your team or whatever. So we would really like to invite all the teams to join to this meeting session. I think it will be useful to join even if you don't have questions. And also in this other document here, we are collecting some answers about problems, for example, about installation of the Android Studio or the Pepper SDK, or about the use of GitHub. So we would like to collect your questions, but then make the answers available to everybody so that whoever has the same problem, of course, can refer to this document. So these are two important resources that we made available for the teams for development. And again, I don't know if someone wants to add something here.
Yes, Luca, can you hear me?
Yes, yes, thank you.
Yeah, yes, Clary speaking. Hello, everybody. So just to say to support Luca in this aspect of the Q&A session. So as SBRE, we are very happy to support Luca and Jeffrey in this challenge. So, and they do a lot to make it possible. So with the other engineers, we will be present during this Q&A session on Monday. So we encourage you to attend this session because, as Luca said, this is an opportunity to ask your question, or even if you don't have any question, you can hear from and learn from the others. And yeah, this is really the opportunity to do it, because we understand it's not easy for you, and yeah, do not hesitate, even if you don't have any special questions. We would be happy, and the more we have people attending this Q&A session, the more we can improve the challenge afterwards as well. So do not hesitate. Thank you.
Yes, and this is also, thank you very much, Clarice, also a good moment to provide your feedback. So it's perfectly fine if you join this session just to provide feedback about the lectures. Would you like more? Would you like less? Is too quick? Is too fast? So please provide also feedback about the material, if you would like to have additional material on some topic, something like that. So it's a very good opportunity to discuss, since unfortunately in this time slot, we don't have many time to interact with you to ask questions. But since we are very used, and now we are in very unfortunate case that we are not making a physical meeting. But during the physical meeting, we have a lot of time of interaction with the teams. So we usually go to the team area and we ask teams, how are you doing? How is it going? Let us know what, let me see what you are doing, and so on. Now, we cannot do this because we are not physically in the same space. So this session should be a little bit the equivalent of when we go around the team area during the physical challenge. So it would be very important that you are present, and maybe we will ask you questions about how are you doing with the team development. Okay, so thank you. And I don't know, just very quickly, the next lecture will make complete examples in which we show how to integrate several components, so dialogues and basic actions of the robot. And we show a very nice example that will be probably similar in terms of a set of functionalities that will be used to your project. And then we will have a final lecture, the sixth one, in which we will see even more advanced programming techniques. So I don't know if there are questions. I didn't have access to the chat. So is there any question that I...
Right, for the meantime, maybe I can add something. Right, I just sent out again the attendance list, so please fill in if you haven't. We will try to collect the attendance for every class. This statistic is very important for us to keep us continue organizing this activity. So I hope everyone can please fill up the attendance list. Also, that's the first thing. Second thing is, as a reminder, I also like to encourage you to sign up for the entry form for the competition. So for the challenge, we really need to gather your information, that teams that would like to join. We need your contact so that we can keep you in touch with our development. So we have some additional messages or anything that we need to tell you for you to prepare. Especially now is almost half of the online classes, and later on you will start to do development. So we have a lot of new information that need to update you, but it is not so appropriate for us to like put all the details to the public, because like we have different audience. So we hope that you can sign up the entry form, even though you're still considering whether it's to join or not, but you are interested in this classroom. So I guess no harm for you to sign up so that you can have some information about the competition. And also, just now for the Q&A session, I think it is also fine if you have any question you want to ask about the competition. Right, Luca?
Yeah, definitely.
Especially for
Absolutely,
beginners,
yes.
Especially for beginners, maybe like you after you listen to the class, it is also very important for you to understand how to apply this in practical, in the application, which is in our case, we use the competition as the platform for us to showcase or to develop actual application. So you want to think of a real scenario for your competition, then you can ask like how to actually implement the things that you learn inside this classroom and how to implement in the real situation. It is totally fine. I think like we can interact this with the engineers, and yes, I think this is a very valuable opportunity, because I don't think it is easy to gather SoftBank robotics engineer to answer you this thing one-to-one. So I hope you can grab this opportunity to have the interaction with us and also with SoftBank for your development. I think this is a very good timing, and it's not easy for us to organize this. So if you respond and we have the numbers, then it is easier for us to justify to offer more of these activities for you later on. Or else it's hard for us to carry on if, let's say, like we don't have much response for you. So hopefully like you can join us. So put out the attendance list, sign up the entry form, and also come to the Q&A. Then we can talk more about your preparation for your competition. So I guess this much that I hope you to tell you at this moment. Right, Luca, you want to summarize? Or?
Okay, no, I think that's perfect. I've seen, I was reading the questions, but I've seen, thank you very much, Emil already answered properly to all these questions. In particular, how to combine other actions is exactly what we will see in the next lecture. So, if there are no other questions or no other comments, I would like again to thank for your participation, and also let me thank also people who are looking at the video afterwards. I know that there are several people that are not in the live session, but they look at the video later on. Of course, what we say is, of course, valid for all the people who are looking at this video. Also, if you are not live at this moment, and in particular, the opportunity for this meeting, of course, is useful for us. Also, let me say that if there is some team that has a conflict and cannot attend the meeting because of the time, let us know. Maybe you send us an email and we try to check what is the situation. Okay, so if there is some team that would like to join this meeting session, but this time slot is not good, let us know and we'll check, we'll try to arrange something different. Okay, so thank you again for participation. Good work. I hope you enjoy working with the Pepper Chat system, and I hope to meet most of you in the Monday meeting and next week for the next lecture. Thank you. Bye-bye.
Thank you very much. Right, see you next week.
See you next week.
Goodbye.
Bye.